Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques video series. Today we are in episode 13, Advanced Modeling Part 9, and we're going to be talking about the Flex feature. Before I get to that though, I want to remind the listening audience about the YouTube videos that we have. And if you go to a particular episode, let's say we'll go to episode 4 here, I want to remind you that I know that many of you are seasoned SolidWorks users, and much of what I talk about you already know, but there might be one or two things that you might not know, and you have something in that episode that piques your interest. Just know that if you click on the Show More button, you can go to the topics that are discussed in that episode. And if there's something that piques your interest, you can go right to that topic by clicking on the timestamp. So here I want to find out more about moving face. I'll just click on that and I can go right to
robust modeling, one of the features that
in the
I
episode.
Employ.
So just as a reminder, I know there's a lot of these episodes that I'm creating and there's a lot of information there. This is a way to getting to the information that you want to know about. So let's move on to talking about the Flex feature. So in today's episode, we'll talk about the Flex feature and how it can be applied to product design. And then I'll bring up a simple Flex example and we'll review the Flex Property Manager, talk about how to fill it out to get your options and your particular flexes, and as well as the options that are involved there. And then we'll look at a few more examples of how Flex can be used, and then we'll finish with a more complex Flex example. So the Flex feature is really not a model building feature, but it's a model modifying feature. That is, it'll work on just existing surface or solid bodies. And it has 4 different options for flexing your part. Probably the most popular one would be bend. And then as you move down the options, you have the ability to twist by a number of degrees. You can taper your model and you can stretch your model. So with that, let's just get into it, and we'll start with a simple example and just review how it works, how you set it up to get your particular flex. So we'll start out with this rectangular bar and we'll go ahead and apply a flex to it. So if you pre-select it, it should come up with the feature already applied to the target body. And past that, you have a number of different options. Let's start with bend. So one thing that you might want to know about is when you first pick your body, it sets up the orientation of the bend along the longest axis of the bounding box of the solid. So that is why this blue line is situated from the front and the back, because it looks at the bounding box and sets up a default bend orientation centered on the part with the trim plane 1 and 2 at either ends of the bounding box. So with that, you can get some immediate results. And so let's just talk about bend. Let's talk about how this works if you've never used this. So the blue line is the direction of flex, and the trim planes are where the extent of that flex happens, in this case bend. And you can use the property manager to dial in your various degrees of bend and radius, but you can also just grab widgets inside the scene graph. So the way this works is your right click on the mouse by holding down on the widget will allow you to bend the object. Now let's move back to 0 degrees. If you don't want the entire object bent, but just portions of it, then with a left mouse click, you can move these trim planes in and then right click on them and then start to bend. Now, what you're seeing here is the portions to the outside of the widget arrows are not bent, but it only bends in between the first and second trim plane. If you want only one portion to be bent, then the trick to that is, let's turn this back to 0 degrees. If you right click on the middle ball of the triad, you can then align that triad, which is the actual bend axis, as you can see here. You can align that with your first or second trim plane. So I'm going to align it with my second trim plane, and then watch what happens. So now that we apply some bending, we are now bending between the trim planes, but the bend axis is situated directly on that second trim plane. So that means that only one portion of the model is bending. Okay, so that is the way the widgets work, and they're very nice because they're dynamic. So with the left click, I can pull back here, and here I can just make this a 90-degree bend. So that is how it is bending between the trim planes with the triad aligned to one of those bends. So let's, I'm going to deselect the model and kind of start over so that we can talk about a few other things. Now you notice that when I started to bend this, it was bending in this particular direction, which is basically the y-axis. If I wanted to change that, I can start to play with the controls down here, or I can take the triad and I can simply just rotate it along an axis. So I can do that by snapping with the triad. I usually like to just kind of get it going in the direction I want it to go, and then I just clean up the values here. I'm going to make this 180 degrees. And again, you can see that the triad's aligned. Well, actually it's not. Let's align it to trim plane 1. So let's go ahead and just say that wants to be at trim plane 1. And then we want to put in a minus 90-degree bend right there. And so that's how you situate the direction of bend, by rotating the triad axis in one of 3 vectors. Now, this makes it look rather easy, but you're going to have to know, if you're going to be doing some flexing, you're going to have to know how to operate this, because a lot of times And I'll show you in a later example, when you bring up the default model, the bounding box is not at perfect 0, 90, and 180 degree orientation. And so you need to kind of reorient it in the way that you want to bend it. Okay, so let's go back to 0 degrees. Let's talk about a few of the other options. So, and let's deselect again. Okay, going on to twisting. So everything applies of what I've just talked about of how to situate the trim planes and the bend axis triad, but you can get different results with different options. So with twist, again, if you want to just twist this between a certain portion of the model, and let's say that we want to put the trim plane 2 on the end of the model, you have the ability to actually snap it to selections on the model. And so that's what I just did. I just made my second trim plane align with the end of my model. And now that I'm on twist, I can then right mouse button on this and I can twist it. And you notice it's only twisting in the portion between the trim planes and the aligned axis. Then I can clean up my value to be 300, let's say we want it to be a full rev, so 360 degrees. So that is twisting. And again, you can dynamically pull on these to change your amount of twist. So I'm going to make that 180 degrees. Actually, I put in the wrong value down here before, so ignore that. This is the actual degree of twists. And then if I want, I can actually pull back on these. Now this one doesn't pull because it's aligned. So what I need to do is just clear that. And then on my left mouse button, I can pull back. And now my twist only happens between my trim planes. Okay, moving on, we have taper. And as you can imagine, with the trim planes that I already have set here, let's just bring this down a bit. What we're doing basically is tapering the model between the trim planes. And we have a value here, or a dimensional offset that we're setting. So we can make it a full 1 millimeter there. And that's what it's doing. It's just tapering down the model in this area. Now, again, right mouse click will actually grow your offset value of the taper. Left mouse button will actually move where you want the taper to occur. And usually you want hard edges on this option. So you get hard edges between the flexed area. If you turn that off, you get something that looks like this. It tries to make it continuous. For flex, it's not especially good. It could be good for some of the other flex types. So let's just cover the last one. Stretching is an interesting one, although I think for most of our SolidWorks models, we can do this much easier by just editing the feature. But maybe there's a lot of detail in here, and this is just a simple example. And you want to actually stretch this area. So again, I'm going to say that this is where I've situated my trim plane, and I'm moving that with my left mouse button. And then on my right mouse button, I'm actually specifying the amount of stretch. And you can see that my my triad is not aligned to my trim plane 1 because the back end is growing. So if I don't want that to occur, move the tag out of the way and just say I want this to be aligned with trim plane 1. Okay, so now when I do my stretch, it's only stretching this forward part. Okay, so again, you have in the Property Manager areas where you can actually specify where you want the triad to be located, as well as the trim planes 1 and 2. and then how much offset you have. And these can be quite valuable because you can have pre-existing geometry like sketch points, and you can actually snap these to those sketch points, and then you can drive your flex parametrically by that previous sketch point or other geometry. As we move to the bottom of the property manager, you have basically a quality setting for your flex, and the higher you move it up, the better quality and also the longer rebuild time. So just keep that in mind. And we'll cover a few more of these in the next example, but that's basically the overview of the Flex Property Manager. So moving to a more practical example, as I said earlier in the episode, I don't generally use Flex as a modeling feature to build models, but I do use it quite a bit to show SolidWorks models in a particular state. And where I use it most often is when I have rigid flex or flex circuits in products that when assembled into my product need to be bent. So I really want to model them flat, but I want to show them as used in a bent state. So this TFT display has two different flex. It actually has three different flexes coming out of it. And we need to bend these back about 150 degrees because the display sits here roughly at about 40 or 50 degrees. And we want these to be bent back where they'll access a PC board underneath this. So I have a solution here. You can take a look at it, but let me just remodel it really quick to show you how I do this usually. So with that flex, I'm going to do a little helper first, and that is, remember how I mentioned that flex can be driven parametrically. So I'm just going to build a very simple sketch here to show where my bend lines are. So I'm going to dimension this one maybe like 0.5 millimeter away from the casing. And then I want to have the end of my bend end up about 9 millimeters from that one, or the first part of the bend. And let's just align this so everything's nice and parametric. And with that, we'll just quit out of that sketch. And so now I can go into my flex feature and pick this body. Now, there's a bit of a problem here, and that is that I really want these to be bent. I have a requirement to have these bent separately because this flex can withstand a larger bend radius than this one can, and I need to do them separately. So if I were to just do that and flex this, and let's go down here, and this is where I'm saying, remember I had said it gathers up the bounding box of the existing body that you've selected, and you can notice that it's really not oriented perpendicular to the default vectors of the origin. So if you go down into this section, you can kind of clean that up by just taking these values and making them what they need to be. And in this case, I notice it's not bending in the right direction either, so I can rotate this around, and then I can move these in, and grab. Sometimes these are hard to grab, but in any case, I'll get to that. But what I'm trying to emphasize here is that if we were to bend this, it's going to be bending both of these flexes at the same time. So what I need to do before I do this, I need to split these apart or go back into my features and separate these as models. Now, sometimes it's hard and there's not a good reason, or it's preventative from being able to change the feature. So in this case, I'll just go onto my top plane and I'll just create a split line between the two and then use the split feature to split this model into two different bodies. Okay, so now I can go back to my flex feature, pick it, and then let's get things aligned first. So I know that this is my direction of bend. So I'm just going to kind of get it going in that direction. I also know that the bend edge is the red line. So that's pretty much oriented correctly. But I have a few degrees here I need to clean up. So 270, 0, and 180 for XYZ. And then I can start to play with my trim planes. Now, this is where things get interesting, because what I can do is, you remember those sketch lines I built here? I can actually say for trim plane 2, I want to select that vertice. And then for trim plane 1, I want the end of my bend to be right here. Okay? And I also know that I want my bend axis to actually start at trim plane 2. And so I'm just going to say I want this to be aligned with trim plane 2. And then I can start bending. And the way you do that again is right mouse over this and drag. And we can bend back. And I want it to be 150 degrees. And there we have our bend. So there's our bend. Now I can go and I can apply a bend again to this one and make it different from my first bend. So I'm going to apply my flex feature. And again, you can see the bounding box is not very smart. It kind of finds the extent of the bounding box, but doesn't mean it's going to be necessarily oriented correctly or the way that we would have predicted it. So again, let's just clean that up a bit by dragging things. So we're just going to get this here, and we're going to make this 0 degrees. And this time around, I'm going to just pull back approximate. I'm not going to use any parametric sketch lines to drive that. And I'm going to say that, I want my bend to be just about in that area. Again, right click on the ball of the triad, want it aligned to trim plane 2. And then I can do my bend to 150 degrees. You can take a look at a side view. These need to really end up on the same plane of the PCB. So what I can do there is start to adjust the triad to match. So I have 150 degrees, and if I pull my triad in the right way, I can change where my bend axis is actually occurring and get that lined up. And I could do that also, remember, with some pre-existing sketch geometry or any kind of geometry. And there you have it. Now what's really interesting about this is that I have a discrete component here that was part of that rigid flex. I can actually include that if I want by just simply in the flex input, just include that body to go along with the bend. Now what happens there is it saw that this now became the bend body, and it changed my bounding box. So it's really, if you know that you're going to include more one body at a time, pick them first, because it's going to pick the last selection to set up the bounding box. And you can see how it reset here in a way that I really didn't want it to. So yeah, so you can include that with it. And I'm just going to pick this and then pick this. And now I have to reorient everything. I'm not going to go through that again, but it's a good exercise. You might want to try this yourself to see what's, how you can get this back to the way I had it. The key is to just turn off the bend by making this 0 degrees first. And then once you've done that, then you can reorient things the way that you need them to be. And again, we're just going to clean up these angles, these arbitrary angles. And we'll do that by dragging things around here and then go down here and clean up the values to be 0 and 180 degrees. And this is 270, of course. And then we're pretty much back to where we need to be. Move the triad back to trim plane 2. And now we can enter our 150 degrees. Go to the side view. We can adjust our triad. Approximately. And I'm glad this happened because this brings up another point. There are times when the deform of the flex feature cannot occur because it's going to create some invalid geometry. So a lot of times you can get around that. What it's trying to do is keep all the hard edges in the original topology. And I find that most times when you run into this problem where you get this error, deform failed, if you uncheck mark hard edges, a lot of times it'll actually solve. And that's the case in this. So anyway, that's the way that I use it usually is for flex circuits, because I do a lot of consumer product design that contain these rigid flexes, and this is very valuable to show it in a flex state and also document it in a flat state for the drawing. Now, one other use case that I can think of for a way that I use flex is to do shapes like this. Okay, so SolidWorks is 25 years old as of this year, 2020. That's amazing. But one thing that I think is still deficient in SolidWorks is patterning, and more specifically patterning in 3-dimension. It does a great job at patterning 2D, but kind of falls apart in 3D because the patterning feature is only limited to certain types of entities, unlike Creo, which can do some really amazing patterning because it can pattern reference features like axes and points and planes. And that's where you can start to create things like this rather easy in Creo, but not easily in SolidWorks. So when I've had to do things like this, I've taken an approach of reverse engineering it to overcome the deficiencies of SolidWorks patterning. And I'll show you how I did that. And this might be useful for some of your use cases. So let's roll back into this part. And what we start off with is, you guessed it, a block. And with that block, we do a cut. And then we do another cut, which uses Derive Sketch. If you never use Derive Sketch, it's super useful for this kind of thing. Basically, I want this one pattern seed to drive this one that I have set up diagonally here. And so any changes I make here will change to the derived pattern. And then I create my pattern. And so I'm patterning in 2 directions up into this quadrant. I take that pattern, I mirror it across the midplane, and then I mirror it again along with the base features for that pattern again. So now I have all of these patterns created off of these 2 cuts. So yeah, so we have that, but it's flat. And the design calls for, let's say this is like a knee pad, it's got to be deformed. It has to be kind of a bent radius, and that would be easy because you could maybe even circular pattern. But in this case, it's toroidal. It's bending in two directions, and those two directions bend radiuses are different. So the approach I took here is, before I did these patternings, I figured out what does that toroid look like. And so with this, I set up some reference geometry in here for my flex. I won't show it right now, but I'm going to delete this face. What I really did here was I basically deleted all the solid and just left the top face with the pattern. And then what I do is I'll take that surface body, remember flex will work with surface bodies as well, and I flex it. So here I am flexing it with a radius of 800 millimeters, and it's just a simple bend. But then I apply another flex feature on top of that, and that's the secret here to getting it to be more than just something that you could circular pattern. So we drop down to our second flex feature, and of course it's an expensive feature. You can see here in this one I'm bending it in the other axis by 200. So now I have a toroidal 3D pattern that once I rebuild here, I can then build another solid and then just do a replace face for this surface body with the top of that block, and then hide the original surface. And so that's how I got that. But you know, a useful way to use flex in a way that you really can't do it in many other ways. Not even deform won't get you as consistent a result as this is, using 2 flexes or even more than 2 flexes. So keep that in mind the next time you run into a tricky problem like this, and it might help you out of it. So I think that's all we have time for today, and I'll move on and get to the next episode.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.